Part A. Use the factor theorem to show that x minus 3 is a factor of f of x. First of all, let's remember what the factor theorem says. The factor theorem says that if f of a equals 0, then x minus a is a factor. So in this case, if I can substitute 3 into my function and show that that equals 0, then that must mean that x minus 3 is a factor. So f of 3 is equal to 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. And that does equal 0. Therefore, x minus 3 is a factor. That is part A of the question done. 2 marks. You need to have all of that information to get both of those marks. Right, moving on to part B. Hence show that 3 is the only real root of the equation f of x equals 0. So what I want to do here is to completely factorise f of x and then show that 3 is the only solution to this. So, to help me factorise this, let's do some algebraic division. So I'm dividing my 4x cubed minus 12x squared plus 2x minus 6, and I'm dividing that by x minus 3 because I know that's a factor. So x into the 4x cubed goes 4x squared times. Because I know that 4x squared times x gives me the 4x cubed. We're now going to multiply that out. So 4x squared times the x, and then 4x squared times the minus 3. So 4x squared times x gives 4x cubed. The 4x squared times the minus 3 gives minus 12x squared. Excuse me. I'm then going to take that away. So 4x cubed, take away 4x cubed is 0. The minus 12x squared, take away negative 12x squared. That's going to be 0 as well, actually. Then we have the 2x, take away nothing, is 2x. And then we have the minus 6, take away nothing, is minus 6. Right, we are now going to repeat the procedure. So we're going to say how many times does x go into 2x, which is twice. Two lots of x is 2x. We are now going to multiply out again. So 2 times the x, and then we'll also do 2 times the minus 3. 2 times the x is 2x, 2 times the minus 3 is minus 6. And we'll take that away. And we notice that that's 0, as we expected, because we knew that x minus 3 was a factor. But the key thing is that allows us to rewrite f of x as being x minus 3 multiplied by 4x squared plus 2. So now f of x has been factorised into a linear x minus 3 and a quadratic 4x squared plus 2. I can now use this to show that 3 is the only real root of the equation when this equals 0. I can do that because 4x squared plus 2 equals 0 has no real roots. Several ways you can do this. You could do it with the discriminant, for example. I can say that b squared minus 4ac, it's discriminant. The b in this case is 0. There is no x term. There's no x term in the middle here. It's a 0x. So b is 0 minus 4 times a, which is 4 times c, which is 2, which is minus 32, which is less than 0, therefore no real roots. So 3 is the only root, the only real root. That's one way of doing it. There are other ways, but that's probably what I would do.